Cool, so today we're going through the theory or the non-calculation of APOW 29 because I'm not paid enough to do APOW 30 calc, so here we go. Question 1. Which one's incorrect? The answer is A. This one's just a solar system question. It's not mostly, it's actually mostly made of CO2, which is carbon dioxide. It does have sulfur dioxide, but it's not mostly made of it. The rest is just correct. Like, Mars might contain water. It also has a tin atmosphere, if I recall correctly. And Jupiter has high velocity winds all year round. This is correct. Neptune is freezing cold and it's ice giant, so you could say there's no solid surface per se. It's gonna fall into it. As for question 2, this is just a test on Kepler's second law. Oops, circled wrong thing, which in this case it will stay the same. Kepler's first law is everything's an ellipse. Second is that the area encompassed is the same. And then third is just the equation that you should know. Which of the below is true? Oh god, what happened? Oops. The sun's sunspot always in pairs. This is correct. The sun will become a red giant, not a red supergiant and not a blue giant. It has yet. I forgot what's the actual value. Let me check. Sun mass loss currently are great. It's been undergoing mass loss over 1 year. Okay, it shouldn't have. 4 point. Okay, I have no idea. How much mass has the sun lost to date? 0.05. So it's not even 1%. So D is wrong. And as such, the answer is B. Because sunspots are formed by like magnetic field lines doing strange stuff. So and as you might know, magnetic field lines they come in pairs. So sunspots are always in pairs. Actually, it's a bit more complicated, but you can Google. Google's your best friend. So like, yeah. This one's just a common sense question. It's an elliptical. So if you search up Messier 87, you will know it is also known as the Virgo A cluster. And you might not know what the hell the Virgo A cluster is, but if I tell you that is in fact the galaxy where astronomers took an image of the supermassive black hole, then you will remember, or you might recall that it was stated that it was from, M87, which is an elliptical. So yeah. As for question 5, what the hell happened here? It is in fact not diffraction. It would be this, like this would be diffraction. The spikes. It's spikes. It is in fact not web-like effects. So it's a bit of a trick question here. So therefore it's not A. Also it's taken by Webb. Because you see the 1, 2, 3, 4. Just saying it's taken by Webb. And then it's not gravitational effects. This is like bullshit. This is also not ring creation. It is in fact does create a fine binary orbit because if you watched the video last week, you will know that I talked about pinwheel stars. Yes, these are pinwheel stars in action once again. And the basic concept is just okay. I need to stop talking about pinwheel stars, but basically there's a point between two stars in orbit where the gravitational pull on the dust is the same. Therefore, it's like cold dust because it doesn't move, and like laws of thermodynamics say that if you're not vibrating, you're cold. So they just chill here. Yeah. And the rings are because of the period of the orbit and all. But yeah, it's very cool. Google it. So question 6. What's true about gravitational waves? Yes, they can. It's just most is too like trivial, like too insignificant, or too like our equipment is not sensitive enough, basically. So yeah. And yes, we can. We absolutely can. No, it is not. No, it's at best GR. At best GR. And I'm not sure if it's GR or something else, but if it's from GR, it makes sense. Wait, who? Gravitational wave theory? Give me a second. Who came up with it? Time to find out. Is it by GR? Yes, it is by GR. Okay, good. So it is general relativity. Therefore, the answer is C. Oh wait, whatever. And for question 7, what is the likely thing? It probably has no magnetic field because it may or may not be like kind of just cooked. I mean, Is it? Should you give me a fat minute? It's a slow rotational period, so it shouldn't be able to have magnetic field. Because magnetic fields... Yeah. Magnetic fields should require rotation. Right? Planets? Give me a fat minute. I didn't set this question, so I'm a bit... Do you need... Yeah. Yeah, okay, I'm quite sure that we need rotation for, like, a reasonably fast rotation. Like, Earth's one is, like, what, 24 hours? Approximately, 23.5. Okay, not important, but yeah, it's probably no magnetic field, or extremely weak. Tidally lock, not necessarily the case. Major impact, no, it doesn't say anything. This one is, like, it's like, what, geosynchronous? Like, solar synchronous? Question mark? Stellar synchronous? Is that even a term? I don't know, man. But this one's a common sense question. It is in fact Eridanus, cause declination. The largest area should be Hydra. I think. Which constellation has the largest area? I think it's Hydra, if I remember correctly. Wait, what? Third largest? Yeah, it should be Hydra. Yeah, Hydra. But for declination, it actually goes to Eridanus. So yeah. Okay, this is slight periodic wobble. It's exoplanet. It's not caused by parallax, so it's astrometry. Radial velocity is like if I said this question, but I forgot. I'm sorry. Radial velocity is what? I think it's by when the planet, cause the line of sight, like when the line of sight changes, and then the radial velocity will change. Because if we're like, I think it's red and blue shifts. It should be red and blue shifts. So this one has something to do with red and blue shifts, and the movement of the star. So but the periodic wobble is due to, I think the periodic wobble is due to gravitational effects. Oh yeah, and the star's position. Okay, I'm so stupid. Okay, I'm not cooking. It's 12:30 and I'm not cooking. Yeah, star's position. Okay, astrometry. Because radial velocity depends on the orbit. It also has to do with red and blue shifting. Whereas astrometry, it does not. It has to do with the star. The star wobble and very slight. This calls for astrometry. Transit photometry, you would expect to see a light curve, which is basically APOW 30 question 9, the light curve that you would have seen, which looks something like this. That would be transit. And microlensing has to do with like gravitational shit, and basically does nothing to do with the wobble. So therefore it's B. So yeah, just like that, we're done. Very good. And yes, I'm just trying to upload everything. So yeah, that's it, and thanks for watching. See you next time.